The last part of this topic that we're going to look at is real world situations that involve Pythagoras' theorem. This could include any of the things we've done, working out if there are right angles, finding the length of the longest side, finding the length of one of the shorter sides. We've got a bunch of different skills we need to cover. And of course, real world situations usually come with real world stories. You may need to even draw yourself a diagram. So there's a bit of application before we can get into the maths that hopefully we have now mastered. In life, we are surrounded by right angled triangles, and that's mostly because we surround ourselves by right angles. The walls on our house, hopefully, are at right angles to the floor. The streets on the ground are typically at right angles to each other. There are triangles all over the place. So let's have a look at what we can do. Well, the first thing is if we get a question, we will possibly have to draw a diagram. So I'm giving us two examples on the screen where both of them require us to draw the diagram because I want to actually show you an example of doing it, not just give it to you. Some of the questions will come with diagrams, some of them won't. Let's practice not. Then we've got to find where in this real world diagram we actually have Pythagoras' theorem turning up. We do the maths, we work it out, and of course at the end of a worded story-based question, we should always write our answer as a story-based answer in some form of sentence or mini sentence, because I know English teachers would tell me that what I'm calling a sentence is not entirely a sentence. So, well, the ones that we use at the end of these. So let's try this. Step one, let's draw a diagram. Well, if you know your directions, a group of hikers walk 4 kilometers due east and then turn and walk 4 kilometers due south. How far away are they from their starting point? Now, obviously, they've walked 8 kilometers, but they are not 8 kilometers away because they turned a corner. So if we start here, one of the things you should always remember, and when you're drawing diagrams, we try and put north pointing up. That's the way maps used to go until we had Google Maps, which spins around when you turn your phone. So we'll just have to live with that. They have walked 4 kilometers east. And at this point, they turn and they walk 4 kilometers south. Now, I didn't have to draw this to scale, as you might call it, but given it fit nicely on the grid, I've done that. Now, if we look at this diagonal, well, you'll see that they are 1, 2, 3, 4 diagonals away from the start, but the diagonal of a square is longer than the side length. So you've got to do some Pythagoras. So where is the Pythagoras in this question? Well, the north isn't part of it, but the lengths are part of it. So what do we need? Well, we've got a triangle. We've got two lengths. We've got a right angle. They didn't actually say that, but obviously north and east are at right angles to each other. So I'll just draw a little right angle, an enormous right angle, a little right angle in there. And then I will say, well, the side we want is to know how many kilometers from the start they are. Now, how far are they from their starting point to the nearest kilometer might have been a better question. So what do we do? How do we do Pythagoras' theorem? Same as we always do. We write out what we know. I know that this is the longest side, so I know that the x squared is equal to a 4 squared plus a 4 squared. 4 squared and 4 squared is 2 lots of 16 is 32. If x squared is 32, then x is the square root of 32, which my calculator can help me with. The square root of 32 is 5.656, etc. 5.656, etc., which is approximately, to the nearest kilometer, it's close to 6 kilometers away from where they started. And of course, what did I say? A worded question, a sentence story question needs to be finished with a story. They are, and we can even use good words here. This is less than 6, so I can say they are nearly 6 kilometers from where they started. Okay, let's try the next question. The guy rope. Yes, I know it might seem sexist or something, but it is actually one of the names given to the ropes that hold up a tent. Some people call them guide ropes, so I don't mind if you want to call it a guy or a guide rope. I think it's a bit Strange anyway, but on the side of a tent is 1.8 meters long and it is attached at a height of 1.5 meters up the side of the tent. Well, how far away from the tent do you need to peg it in so the rope is tight so that the tent doesn't fall over? Well, we're going to draw our tent. Now, it doesn't matter what shape your tent is. You can have a really big, massive tent if you want, but here is the wall of the tent, which they're telling us is 1.5 meters tall. Here is our tent, here is our ground, it should be flat and level, and here is our rope. It is 1.8 meters long, and here is the peg. I hope people have been camping enough to kind of get the picture here. Tents don't always look like houses, but hey, it might be a big circus tent. Doesn't matter. We've got our peg, and the question is, how far from the base of the tent will it need to be pegged? So this is the length we're going to find. So this is the one I'll call X in this particular situation. Again, where is the Pythagoras? Well, the Pythagoras comes in because we now have a right-angled triangle with two sides given and one side we don't know, X meters. So again, we write out Pythagoras' theorem. The longest side squared, 1.8 squared, is equal to 1.5 squared plus x squared. It's always that same format. Something squared equals something squared plus something squared, and we're filling in the blanks. Now, if we're finding the longest side, this will all go in the calculator. If we're finding a shorter side, we can't exactly put this in the calculator straight away, but if we know that these two numbers add up to this one, then I know that x squared is actually 1.8 squared take away 1.5 squared. If I want to be a super duper show off, like many of you know that I am, we could unsquare it right now and put that entire thing into the calculator. Most people won't. Most people will write x is the root of and let the calculator do that work for us. I want to know what 1.8 squared minus 1.5 squared is. It says, oh, it is 0.99. And the square root of 0.99, again, I'll get my calculator back up. We'll hit square root of answer. It says it's still 0.99 because it's so close to 1. 0.994987. Now, I didn't say where to round off. Again, all of these measurements have been kind of had 2 digits worth of number. I don't really think zeros at the front count, so we'll keep those 2 digits. We'll chop it off here, and we'll say this is approximately 0.99 meters. And again, story question needs a story answer. Peg the tent 99 centimeters. Sorry, yeah, peg the rope. We do peg the tent, but that's not exactly what I'm saying. Peg the rope 99 centimeters from the tent to the nearest centimeter. That's what we've done. We've rounded off to 2 decimal places. Nearest centimeter, same thing. All right, this time I'm picking a selection of questions. I don't need you to do all of them. Notice this is 7A, just A, and 11B, just 11B. In your book, contact me if you have any trouble and give it a go, and then show me electronically that you have had a go at it. Don't forget the answers are in the back, so you should be checking your answers before you submit them, but they need to show working out so you and I know that you got there yourself. Don't worry if you made mistakes. I'm more than happy to see the scribbled out answers with the working that then you've either corrected or with a please help, I don't know this question. Don't leave it in there. Put it in the comment as well because it's a bit easier for me to find because I do have to skim through and I can't check everyone's work thoroughly, but I do try and have a quick glance at people's work. So if there's something obvious that says I need help, I will get in touch with you and I will try and help, or I will get in touch with a group of us and we'll organize an online little tutorial thing where we can go through it.